Okay, so there's a few reasons you could be here. One, you've just heard your professor talk about binary search and you have no idea what they're talking about. Two, you're currently studying for your final. Or three, you're simply a super awesome person who's super interested in learning some of the rad things in technology. I think you know which one I fit into. Regardless, let me outline this video. So there are clearly a few categories you should know about. You can skip certain sections as you feel necessary. Section 1, Theory. This section will go over the theory about how binary search works and why it's important to use. I'll demonstrate it using Minecraft. Section 2, Programming binary search in Java. This section will go over implementing binary search in Java from the bottom up. If you have no programming experience, this section will likely not make any sense and should be skipped. Section 1, Theory. So, what is binary search? Binary search is an algorithm that searches for a specific value over a sorted array. Simply put, and for the purposes of this video, think of binary search like this little guy that tries to find a value when looking at an order of numbers. So, imagine you work at a grocery store, and someone tries to return an item that has some sort of item code. You know that your store keeps every item code in an array sorted from the smallest number to the biggest number. For instance, a tomato could be item code number 3, and a banana would be item code number 9. Your job is to check to make sure that the item that customer is trying to return is an actual item in your store's array. So, TLDR, you need to search the array of item codes to see if that item code the customer is providing is actually in there. So that's what binary search does. It basically checks that array to see if that value exists. Okay, so rules to do binary search. Okay, let's see if we can move Kevin a little bit out of the way. All right, rules to do binary search. Arrays must be sorted. So each chest will have an increasing amount of copper. So we have index 0, 1, 2, 3, 4, 5, and 6. And here we have Ebba. So we want to know which one of these chests contains exactly 64 items, and can we use binary search to do it? We're going to look at the center index. This is how binary search works. And it's going to say, hey, is the 32 blocks of copper bigger or smaller than 64? In this case, it is obviously smaller than 64. So that means because the chests are sorted, that index and everything before it can never be 64 because the array is constantly increasing in size. It's the amount of blocks inside of that chest is constantly getting bigger. So now we're left with 3 chests. It's kind of like a small array now. So we're going to do the same thing and look at index 5. And 48 is still smaller than 64. So we'll delete that index and everything before it, and we're finally left with index 6 that has 64 blocks of copper. We'd like to know which one of these chests contains 18 items. This one's a little bit of a bigger example, but see if you can follow along. Just like before, we're going to try to find this middle index. So we're quite lucky here because it is an odd number, which means we can split it perfectly down the middle. In the instance that we can't, say it's 2 middle points, right? There's no way to split it perfectly down the middle. There's no one element that splits either side. You would just prefer to pick one or the other. I typically go with picking the left index, always, but only thing, you can do right index, but you have to be consistent with which one you're picking. You can't just pick the left one, and then when you split the array again, pick the right one. You can't do that. Here, we're going to do index 6, and we check in there. Everything that's at index 6 and before cannot be 18, because remember, the arrays are sorted. Okay, and now we look here. Okay, here's an instance where it's split down the middle. I pick the left index, it's 20, which is higher than 18, so everything to the right of it gets deleted. Okay, we check the left index again, and it's 16, and then we check index 8, and there you go. We have found which chest contains 18 items. Okay, now we can actually start coding. If you don't understand how Java works, I highly recommend you click off the video now, or if you're really ambitious, you can try to follow along, but I do recommend you have some experience before you try to do this on your own. So here I've set up a public class binary search. I have a public static method called contains iterative. This is basically what we've done in Minecraft, where we were trying to find if a certain thing exists in that array. So you can see that it passes the parameters of some type of array and some search value. So what you need to know is the array is the thing that is being searched, like the chests in Minecraft, and the search value is what we're trying to find. So remember when we were looking in the chest, I was saying we need to find 18 of this object? Yeah, that's the search value. So how we're going to set it up. First thing is we need to find the range of the array. So to start, we're going to set the leftmost value. If you're looking at an array, what is the value that is all the way to the left? Starting wise, it's always going to be 0, because you always want to start at the farthest left interval. Arrays always start at 0, so we're going to pick 0. On the right, we want to pick everything that is to the very, 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 very right. So we can find this by pulling the array.length, okay? And then subtracting 1. And this is just because length and actual index is off by 1, because the index always starts at 0, yada yada. We will set up a while loop that says while the left is less than or equal to the right value. So it absolutely will not run if the right value is less than the left value, because then it means the array is not sorted, right? You can't have the value all the way to the right be 1 and the value all the way to the left be 100, because then the array isn't sorted. We can't run binary search on something that is not sorted. So now we need to find what is the middle placement. So remember in Minecraft how we were looking at the chest, we tried to find a middle point and then split it from there and check that value. What we do is we're going to create an object of type V. In this case, it could be anything. It's written in this way for modularity. So we'll say the comparison value equals array at the index of mid. We find mid by doing right plus left divided by 2. You have the comparison value. This is just to say, like, we're actually going to look at the value that is in that position. So remember in Minecraft, we took the middle value, we looked inside that chest. If it was greater than what we were looking for, we deleted everything to the right. And if it was less than what we're looking for, we delete everything to the left, because once again, it is sorted. That's super important to understand. Now we'll take the integer comparison result, and we will set that equal to a search value, which is, once again, the thing that we are passing. We will use the method .compare_to, and then compare it to that comparison value. Then we will check. So the way that the compare_to method works, it spits out an integer value, right? And depending on what that value is, it represents what the outcome of the comparison was. And we can see that right down below. If the comparison result equals 0, then return true. It means that that value that we looked at, that comparison result, is true, and it absolutely matches. We basically return and we basically say, yep, we most definitely have it in the array, there you go. But if we compare and we find that the comparison result is less than 0, then we will reassign the rightmost value to be mid. And then we will subtract 1, because we know that mid cannot be a point. So remember in Minecraft how it was like when we found the midpoint, we checked it and that one did not line up. We deleted both mid and everything before it. So that's kind of what's happening here. The rightmost value is going to be reset to mid minus 1. Because we've reassigned what the right value is, it's cutting off everything to the right of it. We're no longer looking at what's happening to the right of that mid value. And then else, if all else fails, it means left will be reassigned to mid plus 1. Once again, 1 is getting added so that mid is accounted for, and we're cutting off everything below it. And then, so basically that while loop will keep going, and it'll keep reassigning right and left until it either returns true, or the while condition becomes false, and it returns false for the entire function.